So the double angle formulae are sine 2 theta is equal to 2 sine theta cos theta, and cos 2 theta is equal to cos squared theta take sine squared theta. Now if we're interested in proving this, well then I would start with an isosceles triangle. So isosceles triangle, I've got two sides equal there. It may not look like it, but we'll just say they are. And I'm going to draw the line from the apex to the midpoint of the base, which bisects this angle in here. So if I use some different colors, if I color in that whole angle, well, that's the whole angle, and then if I just color in half of it in blue, well, we're going to say that this blue angle here is theta, and the green one therefore is just double that, which is 2 theta. So now I'm interested in proving this, and I'm going to call this side A. Okay, now here in this right-angled triangle, which I'll outline in red, I can use some basic right-angled trig ideas. So I've got the angle of theta up there, and so within this triangle I can say that cos theta is equal to, well, I'm going to say this is the height of my triangle, so it's equal to height over A. So the height of this triangle is A cos theta. Now, half the base, which I'm just going to call B, I can also use right-angled triangles, so I can say that sine theta is equal to B on A, so B is equal to A sine theta. Okay, so where are we going? Well, we're going to use this to be able to find the area of my triangle. So area of triangle is equal to half of the base times the height. Now, the base in this case is twice b, so it's going to be half times 2b times by h, because we said b was just half of this bottom side. So it's going to be half times by 2a sine theta, that's what we found b was, times by a cos theta. So if I put that all together, the half and the 2 will cancel, the a will multiply by itself, so we get a squared sine theta cos theta. Okay, but we also know that the area of a triangle is a half AB sine C, where A and B are two sides of the triangle and C is the angle in between. So if I take my two sides as this A and this A, the two equal sides, then the angle in between is 2 theta. So it's a half times A times sine of 2 theta, which is a half A squared sine 2 theta. So I've got the area of this isosceles triangle in two different ways. So these two ways must be equal. So we can say that a half A squared sine 2 theta is A squared sine theta cos theta. And so I can cancel out the A squareds, so I get that a half sine 2 theta is sine theta cos theta, and then I can just multiply both sides by 2. So if I multiply 2 by a half, that'll cancel. So I get sine 2 theta is just 2 lots of sine theta cos theta. And so that is the proof of this sine one. But that's not all. What about cos? Well, let's take my same isosceles triangle. Line from the apex to the midpoint. I'm going to say this is A, and we know that all of this, I'm colouring it in blue now, is 2 theta, and then half of this is just theta. And from what we did before, if we call this side A, then we can call this one A cos theta, and we can call this one a sine theta. So that's just half of that. Now, let's use the cosine rule on this triangle. Now, you might be a little reluctant to do that, and I understand that. But the cosine rule says that c squared is equal to a squared plus b squared, take 2ab cos theta, where we've got a triangle. This is A, this is B, this is C, and the angle in there is theta. Okay, so in this case, our C side, our base side here, is 2 lots of A sine theta. So we're going to square that, and then we've got A squared plus A squared. There's the two sides that are the same length, and it's going to be take 2A times cos of 2 theta, because the angle between the two equal sides is 2 theta. So now I get 4a squared sine squared theta is equal to 2a squared take 2a squared cos 2 theta. So cancelling out my a squareds, I get 4 sine squared theta is equal to 2 take 2 cos 2 theta. And then dividing everything by 2, that cancels down to 2 and 1. They'll just cancel down to 1. And over this term, those 2's will cancel down to 1. So I get 2 sine squared theta is equal to 1 take cos 2 theta. So, swapping that around, I'll get that cos 2 theta, or minus cos 2 theta, is equal to 2 sine squared theta take 1, and then if I go through and divide everything by minus 1, I'll get cos 2 theta is 1 take 2 sine squared theta. Now you may recognize that as one of the double angle forms, but it's not the one we're looking for to prove, but we can move fairly interchangeably between the two, so I can write sine squared theta as 1 take cos squared theta. So I get cos 2 theta is 1 take 2 plus 2 cos squared theta. And so we get minus 1 plus 2 cos squared theta, or 2 cos squared theta take 1. So it's cos 2 theta is equal. That's the other form. Again, it's not actually the one we're looking for. So the one we were looking for was cos squared take sine squared equals cos 2 theta. So if I write 2 cos squared theta take cos squared theta plus sine squared theta, I'll get that that's equal to 2 cos squared theta take cos squared theta take sine squared theta, and 2 cos squared theta take cos squared theta just gives me cos squared theta take sine squared theta. And that's the three forms of cos 2 theta. Okay, and that's the proofs of the double angle formulae.